was a program manager leading a cross-functional program within an e-commerce returns center handling 34,000 units a week. Customer refunds slowed while headline productivity remained on target, and supervisors attributed it to inexperienced seasonal staff. I needed to find why refund cycle time had risen from 19 to 36 hours without blaming the visible symptom. I reviewed staffing, training, system latency, product mix, and the physical journey of delayed units rather than immediately adding labor. I spoke with refund agents, shadowed 6 totes end-to-end, queried scan timestamps, and compared fast and slow cohorts. 71% of delay sat between grading and finance release, concentrated in mixed category totes created after 3 p.m. I traced the handoff and found one status code sent mixed totes to a twice-daily exception queue. I changed the sorting rule, added an hourly sweep, and built an age report by process step. IT initially saw no defect because every message eventually completed. I showed the timestamp distribution and recreated the delay with a test tote, turning an operational complaint into a reproducible failure. The first rule change overloaded one specialist queue, so I split high-value electronics from standard exceptions and cross-trained 4 agents before widening the change. Before closing the action, I sampled performance across different shifts and demand conditions, so the result did not depend on one unusually experienced team or a quiet operating window. I translated the outcome into a simple frontline mechanism with a named owner, an escalation threshold, and a weekly measure, which made the change repeatable after I stepped away. I also documented the operating assumptions, named the owner for each follow-up action, and set a clear review date so that temporary controls could not quietly become permanent. I wrote the decision, assumptions, owners, and stop conditions on a 1-page control plan so the next shift could challenge the logic rather than rely on verbal context. I used both a leading indicator and a customer outcome measure that prevented a short-term productivity improvement from hiding quality, safety, or backlog age. During implementation, I stayed at the operating point for the first cycle, asked frontline employees what the mechanism missed, and changed only one variable at a time. I assigned named owners for each checkpoint and made escalation thresholds visible in the shift huddle, which reduced ambiguity when I was not physically present. After stabilization, I compared the result with the original baseline, checked for cost or defect displacement, and documented the mechanism for the other shifts. Before committing, I asked a supervisor who disagreed with me to identify the weakest assumption, then converted that concern into a measurable checkpoint rather than relying on consensus. I separated mandatory controls from preferences, which let the team move quickly without weakening the safety, quality, or customer promise that the operation existed to protect. For each alternative, I estimated the likely customer impact, labor requirement, operational reversibility, and worst credible failure, and I explained why my chosen path offered the best balance. I briefed affected teams before launch, checked understanding through questions rather than attendance, and made the escalation route clear to people working outside my shift. I also protected normal operations by defining which work would pause, which work would continue, and who could authorize expansion beyond the initial controlled scope. At every review point, I compared actual performance with the assumption that justified the decision. When they diverged, I changed the plan rather than defending the original recommendation. I made the cost of the choice visible as well as the benefit, because hiding overtime, rework, or displaced backlog would have made the result look stronger but less useful. Once the immediate issue was resolved, I held a short review with frontline representatives and partner teams, captured what failed in the original mechanism, and assigned permanent actions. Median refund time returned to 18 hours, aged backlog fell 82% in 5 days, and productivity improved 9% without extra headcount. Seasonal worker error was only a minor contributor. I dive deep by following individual work through the system, reconciling frontline experience with timestamps, and testing the causal mechanism before scaling a fix.